In this video, we are going to be looking at how you would calculate the percentage composition by mass of a substance. To calculate percentage composition, we need to follow 3 steps. Step 1, work out the gram formula mass of the substance. Step 2, work out the mass of the element in question. And step 3 is do the percentage calculation. So it's the mass of the element divided by the gram formula mass for the compound times by 100. Now we are going to look through some worked examples of these calculations. Question 1. Calculate the percentage composition by mass of hydrogen in C10H14N2. So the first thing that we need to do is calculate the gram formula mass. Here we have 10 carbons, so we have 10 times 12. Remember, for gram formula mass, you times the number of atoms in the substance by the relative atomic mass of that element. We then add all these figures up and we get a gram formula mass of 162. That's part 1. Part 2 is to work out the mass of the element in question. Here we're asked about hydrogen, and we can see from the question that we have 14 hydrogens. So the mass of the element in question is just 14 grams. And step 3, putting it all together, the percentage composition is 14 divided by 162 times by 100, and that gives us an answer of 8.64197, and so on. And of course you will need to round that, so we round it to 8.6%, and that is our final answer there. Let's continue to work through some examples of these together. So our second one, calculate the percentage composition by mass of magnesium and magnesium nitrate. So this is a bit more difficult example for the simple fact that we're looking at complex ions and we've got brackets involved. So here we have 1 magnesium, so it's 1 times 24.5. However, when we start to look at nitrogens, we have to remember that everything inside the bracket is multiplied by this 2. So we have 2 nitrogens, 2 times 14, so that's 28. And this time we have 2 times 3 oxygens, so we've got 6 oxygens, 6 times 16, which is 96. And when we add these up, we should get 148.5. We're asked in the question about the percentage composition by mass of magnesium. So for the second step, we are looking at magnesiums. We only have 1 magnesium this time, so it is 24.5. So when it comes to doing our percentage calculation, we have 24.5 divided by 148.5 times 100. And if you do that sum, it should work out to 16.5% after rounding. Let's look at some more examples. Here in question 3, we are asked to calculate the percentage composition by mass of oxygen in C6H12O6. Again, our first step is to calculate our gram formula mass. Carbon has a relative atomic mass of 12, so it's 6 times 12, which is 72. Hydrogen has a relative atomic mass of 1, so 12 times 1 is 12. And as before, oxygen has a relative atomic mass of 16, so it's 6 times 16, which gives you 96. If you add all these up, you get to 180. The second step is asking you about oxygen. We have 6 oxygens in the sample, so we are going to have 6 times 16, which gives us 96. And when we're working out the percentage composition by mass, we take the mass of the element in question, we divide it by our gram formula mass for the compound, and if we times that by 100 and work it out, we should get 53.3% after rounding. Now, in the examples that we've looked at so far, they have been relatively straightforward and you have been given the correct formula. However, sometimes the questions will not give you the formula and you're expected to work it out for yourself. So in this example here, you can see you have to calculate the percentage composition by mass of nitrogen and ammonium nitrate. This time, your first step is to work out the formula for ammonium nitrate. Here we have to use our valency rules, so we can put aside symbol, valency, swap, divide and formula. Ammonium and nitrate are both complex or group ions and you will find them in your data booklet. The symbol for ammonium is NH4 and it is a wee positive side, and nitrate is NO3 and a negative sign. Now with ionic formula, remember that the charge equals the valency, so we have 1 positive, so our valency must be 1, 1 negative, our valency is 1. We swap the sides, we cannot divide them, so when we write our formula we write NH4 NO3. We are now able to take this on and calculate the gram formula mass. So here we have 1 nitrogen and we have 4 hydrogens. We have another nitrogen that appears in the nitrate part of our formula, and we have our 3 oxygens. And when you add that up, you will get 80. Now when it comes to working out the mass of the element in question, you have to be careful in this example because the nitrogens are separated in the formula, and this is where some people can make a mistake. So here we have 2 nitrogens present, so we have a mass of 28 grams, and that is what we use in our percentage composition calculation. So 28 grams of nitrogen over the gram formula mass of the compound times by 100. 28 divided by 80 times 100 works out to be an even 35%.